Does the secret of chance, true randomness, actually lie in quantum science? We're going to be analyzing the speculative, but I think rigorous connections between subatomic indeterminism and the whole architecture of human consciousness.
And it really is one of the biggest conceptual chasms in science today. We're talking about the fundamental role of chance that's just inherent in quantum mechanics versus the classical determinism that, well, seems to govern everything we see in our world.
Exactly. The core issue we're tackling is whether this fundamental randomness that's been proven at the subatomic level, what physicists call ontological chance, is actually relevant to human experience. Or, is it just washed out by the sheer scale and complexity of the brain?
Right. So we are questioning the proposition that quantum phenomena, things like entanglement and this intrinsic randomness, are necessary to solve what's called the hard problem of consciousness or to explain some of these reported anomalous mental effects.
And I'll be arguing that quantum principles, they offer the most compelling theoretical framework we have for non-local mental phenomena and the subjective, irreducible experience of consciousness, what we call qualia. Classical physics just leaves an insurmountable explanatory gap.
And I'm going to maintain that applying quantum theory to a large, warm, wet system like the brain is fundamentally flawed. It just runs up against well-established physical constraints, and the biggest one is thermal decoherence. This, for me, renders these claims highly speculative, no matter how much you might want indeterminism from a philosophical standpoint.
Okay, so my position starts with the classical view. The Newtonian picture of physics, it's rooted in objective properties, form, number, motion. It has historically, and I'd say deliberately, excluded subjective sensations, these qualia. Qualia is the felt element of experience, the redness of red, the actual pain of a headache. You can't reduce that to just neural firing patterns. This is the hard problem of consciousness that David Chalmers formulated. And classical mechanics is frankly entirely ill-equipped to bridge that gap between physical brain activity and subjective feeling.
I see the problem you're trying to solve.
Right. And this is precisely why the hypothesis of a quantum mind, most notably the orchestrated objective reduction, or ORCH-OR model from Sir Roger Penrose and Stuart Hameroff, is so appealing. It suggests that phenomena like superposition and entanglement are essential, irreducible parts of consciousness. Their model suggests these quantum processes could happen within neural microtubules, which are these tiny protein structures inside our neurons. And beyond that, proponents argue that entanglement offers the only framework for understanding reported psi experiences, things like telepathy, arguing that these are just the human experience of quantum interconnectedness, defying all the classical rules of space and time.
Okay. I see why you find the quantum mind concept necessary, especially given the failures of classical models to account for qualia. But necessity doesn't equal physical possibility. I come at this from a different angle, one rooted in, physical reality. The foundational scientific barrier for any quantum mind theory is the need for sustained quantum coherence. Quantum effects, they rely on systems remaining isolated from their environment. But the brain is an incredibly complex, warm, noisy macro structure. It's the worst possible place for it. And the critical assessment here really comes from the physicist Max Tegmark. He rigorously calculated that quantum coherence in structures like microtubules would collapse far, far too quickly, on the order of femtoseconds, that's 10 to the minus 13 seconds, to influence any relevant neural processing, which happens on the millisecond timescale. This massive disparity, it's a gap of roughly 12 orders of magnitude. It just invalidates the basis of models like ORCH-OR. And beyond that, applying QM to consciousness has been criticized as mystery reduction. You're linking two deep, unresolved mysteries, consciousness and quantum reality, and claiming it's an explanation. It's not. It just replaces one set of unknowns with another.
That's an excellent point about Tegmark's calculation. I'll grant you that. It is the strongest physical challenge to the ORCH-OR model, no question. However, I would frame the counter-argument around biological robustness. The standard decoherence calculation is formidable, yes, but it relies on a very generalized model of the environment. Hameroff's group contends that biological mechanisms might actually be structured to circumvent or at least delay that environmental interaction.
How, though? The physics is pretty clear.
Well, they suggest cellular shielding mechanisms. Things like the Debye layer of counter ions that surround the microtubules, or the specific, near-perfect crystalline structure of the microtubule lattice itself. These could enable a kind of quantum error correction, or actively screen out thermal noise. And this isn't just, wild speculation. Recent experimental results do support the potential for robust quantum states in these kinds of biological architectures. For instance, studies have confirmed superradiance, a kind of cooperative light emission, in networks of tryptophans, which are amino acids you find right there in microtubules. This demonstrates that cooperative quantum effects can support robust quantum states, even in warm, noisy biological settings.
I'm sorry, but I just don't buy that these biological mechanisms can bridge the colossal timescales required. Decoherence isn't just a theoretical problem. It's a rapid physical interaction that forces a system back into a classical state almost instantaneously. The idea that some cellular shielding provides enough isolation to jump from femtoseconds up to the millisecond timescale, it remains fundamentally problematic. Even if superradiance suggests some short-term quantum activity, that doesn't prove the sustained, long-lived quantum computation you would need for consciousness.
But it opens the door.
It barely cracks it open. In fact, critical assessments of those superradiance studies often point out they may not accurately reflect the in vivo environment. They frequently exclude things like endogenous ferritin, which is known to interact with and quench microtubule fluorescence in living tissue. The physics of the brain, a hot, wet environment, is inherently resistant to maintaining long-lived entanglement. And more importantly, let's say coherence persisted for milliseconds. What's the mechanism? What physical mechanism links the quantum state of a microtubule, the collapse event, to the firing pattern of a classical neuron? If you can't specify that link, the explanatory gap remains, no matter what.
And this brings us to the heart of the philosophical matter, which I think justifies the search for a quantum mechanism, even if the physics is challenging. Since classical determinism is insufficient, the only justification for the quantum mind is the need for fundamental indeterminism. So let's shift focus to that essential quality QM introduces: ontological chance. Classical determinism, Laplace's demon, says if you know the initial conditions, the future is certain. But the Copenhagen interpretation of quantum mechanics says the result of a measurement, like which path a photon takes, is fundamentally random. It's true chance. This was proven experimentally by Alain Aspect's work violating Bell's inequalities. It's a true break from determinism, and it's the non-algorithmic indeterminism Penrose finds necessary to escape the idea of the mind as just a computer.
That is a compelling argument for the existence of chance in nature, I agree. But have you considered the philosophical utility of pure chance for something like human autonomy or reasoned choice?
I think it's the only way to get it.
I'm not so sure. If you replace determinism with pure randomness at the foundation of the mind, you haven't solved the problem of free will. You've just traded control for chaos. I mean, historically, think of Epicurus's atomic swerve. That kind of argument required chance only to provide alternative possibilities, to break the causal lock. But the selection of an outcome still required agent autonomy, a rational will, to preserve moral responsibility. If QM just provides random chaos, how is human reason preserved? If your decision to raise your hand is just dictated by a probability distribution collapsing randomly in your brain, that isn't reasoned choice, it's physical caprice. It runs counter to the very idea of consciousness.
But the proposal isn't for pure quantum chaos. It's a modest indeterminism that occurs at the boundary of objective reality, during the objective reduction process in ORCH-OR. This isn't just random noise being amplified. It's a process that opens the system to non-algorithmic input. It's proposed to be non-computational and physically driven by gravity, providing that essential break from the causal chain without devolving into simple randomness. And besides, the very persistence of anomalous mental effects suggests consciousness already operates beyond classical locality. Think about the empirical evidence. Rupert Sheldrake's studies on telephone telepathy, knowing who's calling before you answer, show success rates of 42% against a 25% chance baseline. Under blinded conditions, that's statistically significant. And what about scophthesia, the sensation of being stared at? It's reported by up to 97% of people. These are consistent anomalies that should compel us toward a new paradigm.
Well, I am not convinced by that line of reasoning because the credibility of parapsychological evidence is, to be blunt, highly suspect. The broader scientific community rightly demands rigorous reproducibility, and that field is, well, characterized by methodological shortcomings. It's plagued by experimenter and publication bias.
But the data is there.
Let's look closely at that data. The experiments with psychokinesis and random number generators, like the Global Consciousness Project. It's true, the cumulative result over 17 years did reject the null hypothesis. Something non-random was happening. However, a detailed analysis does not support the grand narrative of a global consciousness correlating with world events. Peter Bansol's rigorous review concluded the results strongly favor a goal-oriented effect associated with the experimenters themselves. That's a huge distinction. The data may show anomalies, sure, but it's likely related to experimenter interaction, a known methodological problem, not proof of a non-local quantum mind.
But if we assume that any consistent deviation from chance requires an explanation, then classical science has no adequate model for even a goal-oriented effect influencing a distant RNG. My point is that these persistent, small effect sizes are exactly what you might expect from a weakly coupled quantum system. While the mechanism needs work, the observational data, whether it's telepathy success rates or RNG correlations, suggests genuine anomalies that must, by definition, push us beyond classical physics.
I just don't think the evidence is strong enough to warrant that leap.
So, we have really highlighted a crucial conflict today. I've argued that the principles of quantum mechanics, entanglement, non-locality, ontological chance, provide the revolutionary tools we need to bridge the explanatory gap in consciousness and account for these consistently reported anomalies. Without invoking a new physics, consciousness remains fundamentally unexplained.
And I would caution that rigorous physical principles, particularly the rapid timescale of decoherence, severely restrict applying QMD to the human brain. While quantum mechanics provides a basis for genuine indeterminism in nature, the question of whether this quantum chance is accessible or, frankly, even relevant to the human mind remains one of the greatest unresolved debates. The challenge for the quantum mind hypothesis is still to demonstrate a physically viable mechanism for sustained coherence and, crucially, to link that quantum reality back to the classical world of neurons.
Thank you for joining us for this discussion on The Debate. We hope this exchange has illuminated the intense challenges involved in linking the mysteries of the quantum world to the mysteries of the mind.
If you found this exchange illuminating, please help us reach 2,000 subscribers and share this show. Lay Podcast Affiliate.